This is our project Wheeled Robot to study soil and atmosphere. And these are our team members. This is the presentation overview. So, wheeled robots are used in many rough terrains, thus making the job easy for the humans. Soil and atmosphere plays a major role in many industries, mainly in agriculture sector. There are many parameters which are important in agriculture for a healthy plant growth, like soil moisture, humidity, pH level, etc. These parameters can be adapted for modern irrigation systems to save water and to avoid crop failure. So our main objective is to create a wheeled robot which calculates soil and atmospheric parameters like pH of the soil, humidity of the air, etc. To implement the concept of Bluetooth module for the movement of the robot, and to create an app which can control the movement of the robot. To design a simple robotic arm with the sensor as the end effectors. To make this robot cost effective as possible to make room for future improvements as well.
So this is the literature review of this for this project. So these are the some of the authors of some research papers from which we have referred for our project. For instance, we have referred for connecting the Bluetooth module along with the Arduino, and to connect the sensors like humidity and the pH value sensor to the Arduino board, and to control the DC motor using the Arduino, and to control the robotic arm, that is to control the servo motor using Arduino from the command. So this is the methodology of this project. This is the simple block diagram of the process which has been done. So basically the process is we have created a mobile app in which we connect to the Bluetooth module in the robot. From the mobile data from the mobile app, we send commands for the movement of the robot. So these commands are received by the Bluetooth module, and the commands will be fulfilled by the Arduino, which sends the command to the motor driver, which controls the motors for the movement of the robot. And the data for the robotic arm movement is also sent to the servo motor, which acts as the robotic arm, in which the end effectors is the sensors. So it is turned in such a way that it touches the soil, so it collects the data like humidity and pH value of the soil, like that. So also after the contact with the ground, the sensors collect the data and sends it to the Arduino board, and these data can be displayed using the LCD display, which can be utilized for the projects. So these are some of the hardware and software we have used in this program. These are the components like Arduino. We have used the servo motor for the rotation of the robotic arm, and the L29-8N motor driver, which controls the motors, and the 200 RPM motors for movement of the robot, and the Bluetooth module as said before, and some of the sensor like humidity sensor, pH sensor, and moisture sensor, and some of the LED services. And the software used here is the Arduino IDE program to program into the Arduino board. So these are some of the results. This is the work completed until now. So due to this tight pandemic conditions, we were unable to purchase some of the components. So we are about 85% complete. So this is the design of the app I told about. You see this left side, we have the up and down button, which is for the movement of the robot, forward and reverse. And the buttons on the right is for the left and right motion. And the buttons at the center is for the up and down motion for that uh, the servo for the movement of the robotic arm. Next page. So this is the building block of the app which I have created.
So coming to the codes we have used in the Arduino for different components. So this is the movement of the robot code. As you can see, like we have this code will be implemented in the L298 and motor driver for the control of the robot, and then also the robotic arm, which will be this code will be also connected to the servo motor. Thus, we are controlling the movement of the robotic arm as well, and we are also setting up the Bluetooth client for the communication with the controller app. Next. Next. As you can see, this is the continuation of the previous code. Next. So this is the temperature and the humidity sensor code. So like first we are like including the library of dht.h, and then we are defining the dht pin to 2, and then we are defining the dht type as dht11 sensor. So dht11, we are using dht11 sensor, and then we are connecting the S pin of the sensor to the pin 2 of the Arduino port, and then like we are defining the like delay as delay ms, and then we are setting up the serial port to 9600 baud rate for serial communication, and then we are enabling the DH to begin. Now coming to the sensor, so like first we will be obtaining the temperature, which is the function like dht.temperature. We'll be obtaining temperature and then we'll be printing it. So first we will be displaying the features of the sensor, which is the inbuilt function of the Arduino. So first we'll be displaying the sensor type, driver version, unique ID, maximum value that the sensor can obtain, and the minimum value the sensor can obtain. Next. And then the resolution of the sensor. So like coming to the humidity details, like we'll be obtaining the sensor type as well, and then driver version, unique ID, the maximum humidity that the sensor can obtain, and the minimum value, and the resolution of the sensor. And then we'll be setting up some delay for between the sensor reading and the sensor reading based on the sensor details. And then like we'll be setting another delay for the between the measurements. Next. So this is where we'll be obtaining the temperature. So in this case, like we are checking if the sensor read function we are using in correct sensor type or not. If it's not a correct sensor type, we'll be displaying error reading temperature. Otherwise, it will be displaying the temperature value with degrees Celsius. Similar for the humidity case, we'll be getting the humidity value, and then we'll be we are checking whether it is obtained from a correct sensor type or not. Then we are printing the humidity percentage value. So next, this is the servo motor code. So we'll be using the servo motor for the robotic arm to place the moisture sensor in the soil. As you can see, like we are rotating the servo motor to 180 degree to and then we are controlling the robotic arm using the controller app as well. So
we are going to see our hardware results of our project. Next, this blue color sensor here used is our temperature and humidity sensor, and the type is DHT1111, and it uses a capacitive humidity sensor and thermistor to measure the surrounding air. And in our if we are putting that DHT 1111 in our code, actually from the library we can get the values, driver versions, unique ID, maximum value, minimum value, and resolution for both the sensor types. And at our room temperature, we took the reading was taken as for temperature 32 degrees Celsius and humidity 52%. Next. So you see, this is the prototype of our project. The LEDs are connected according to the it's respective to the front, back, left, and right movements. The yellow LEDs for the up and down motion of the robotic arm. Next. This is the app we created for the movement of our bot. So respective buttons uh, are placed for or are pressed if, for the respective movements. And this is the wheeled robot which will carry our sensors and stuffs. And this is a servo motor for the up and down motion for our robotic arm. Here we can conclude that our project mainly focuses on building a wheeled robot with an robotic arm to check various parameters like pH, humidity, and moisture, etc. The observation can be read widely across the different regions with the help of wheeled robot, which can move through tough fields. So, if the parameters are useful in industrial and agricultural sectors. These are the references where we took the these are the references where we took to complete the project. Then thank you.
Now we move on to the video demonstration.
So this is the sensor we'll be using for our project. So you can see this is the sensor over here and have connected to the Arduino board. This is a DHT11 type sensor which will sense the temperature and humidity in the atmosphere. So as you can see, it is now active and have powered it. You can see in the serial monitor over here. So this is the sensor type DHT11, and then you can see the temperature is around like 34.3 degrees Celsius and the humidity is 67.00 degree percentage.
Of our project, as you can see the setup, we'll be implanting this prototype to this robot over here. This is the L2918 motor driver. These are the wheels connected to it. Let's come to the app which we have built. So yeah, this is the app we have built. So first we have, as you can see, this is the Bluetooth module. So now it's like blinking continuously. Let's connect to the Bluetooth module over here. So now we are connecting to the Bluetooth module. When it connects, go to the app and then you can see the blinking stops. So let me demonstrate the app for you. Now if you click the move straight button, you can see the LED is on over there. So this is the move straight button, move back button, and then the move right button, move left button, and then this is for the servo motor which will be using as an actuator. So this is the servo motor up and then servo motor down. As you can see, the app is working perfectly. So now we will be implanting this code to the wheels and the actuators over in this robot. So yeah, this is our project. Thank you.